Hey there, y'all. Today we're going to look at 3.3 on evaluating functions. And so the objective of this lesson is that students will be able to evaluate functions for a given value. And our standard here, FIF2, is to evaluate functions and interpret the meaning of expressions involving function notation from a mathematical perspective and in terms of the context when the function describes a real-world situation. Let's first talk about what is function notation. And so function notation is a notation, a way to write, that shows the input value with its output result. And so this allows us to see both what the x is and the y at the end of what we're doing. Because what we're used to doing is plugging in a value for x and then getting y equals a number. But we forget what we had originally plugged in. Function notation takes care of this issue. And so let's talk about how we actually read this notation. So when you see this f parenthesis x, you don't say f parenthesis x because it's not some multiplication. It's f of x. And so if we see this, we read that as f of 3. Or if we were to have this, what would this say? This would be f of negative 4. And so f is the common letter to use for functions, but it doesn't always have to be. We could use g of x, we could use h of x, h standing maybe for height, for h of t, and so t would be our time. Or we could use c of t, the cost of producing a product. And so we could use any letter we want for both the function notation, the open letter, and also the input variable being the one inside. And so when we think about functions, that f of x is just replacing y. So when we look at f of x is equal to 2x minus 1, we're really just saying y equals 2x minus 1. And we can go the other way as well. If I've got y equals negative 2/3 x minus 5, I could rewrite it as f of x is equal to negative 2/3 x minus 5. And again, the part in the parentheses is always going to be the independent variable that is in the problem. So those variables are going to match. Okay? The variable outside is like your y. Now, we don't say y of x typically. We can. I mean, there's nothing wrong with it. It's another letter. But we're typically going to use f or g or a letter that is a part of the word problem. Again, what's our output? So if we're dealing with height, we would use h. If we're dealing with speed, we might use s or v for velocity. And again, that's the notation we'll use. So let's look at a couple of examples of how we evaluate functions. So in example 1, we're going to look at f of x is equal to 4x minus 5, and we want to evaluate it when x is equal to 6. And so when we see this, we're going to put that 6 in for the x. And so we're going to say f of 6. Now, you're never going to touch that number 6 again. You're going to leave f of 6 at the front of the problem the entire way. So you could actually come down here and write f of 6 and f of 6. With however many lines you need, you're never going to move that. You're never going to change it. You're never going to touch it. Just bring it straight down every time. Okay? Now, we're plugging in 6 for our independent variable. So everywhere that we see the x, I'm going to replace it now with 6. So I've got 4 times 6 minus 5. And so we do our order of operations. Multiplication first. 4 times 6 is what? 24. And 24 minus 5 is what? 19. And so what we get is that f of 6 is equal to 19. Now, that relates back to an ordered pair. Remember that this is your x and this is your outcome. This is your y. And so this would represent the ordered pair 6, 19. And so again, that's the connection we're going to make as we go towards graphing functions in Unit 4. Now, we could do a similar problem. We can still do f of x is equal to 4x minus 5, but maybe the direction says that we want to find f of negative 2. So I can do a whole nother evaluating of this function with a different input value to find what its output value is going to be then. And I would do the same steps. I'd have f of negative 2 is equal to 4 times the negative 2 minus 5. And so we would do our order of operations and get our answer. So if you want to work ahead real quick, pause the video, see the answer that you get. So let's see what it is. F of negative 2 is equal to negative 8 minus 5, and f of negative 2 is equal to negative 13. Now again, this is your answer, but if we were going to take this and put it on the coordinate plane, what would be the ordered pair? Remember, the number inside the parentheses, that's your input value, so that's your x, and the number that you get equal to is your y. So this would be negative 2 and negative 13. So again, we're taking our input value, putting it everywhere we see the variable, and doing order of operations. Okay, let's look at another example of this. Also do this for higher order functions, so like second degree or third degree or whatever power that might be involved, but the steps are still the same. We're going to input our value and then find what it's equal to. And so in this case, we're doing f of 5. So f of 5 is equal to, everywhere I see the x, I will replace it with the 5. And remember, anytime you substitute, you need to put that number first into parentheses and then do your order of operations. And so negative 2 times 5 squared plus 3 times the 5 minus the 4. So again, everywhere I saw x, I've replaced it with 5. Now again, like we talked about in the previous example, I can bring that f of 5 down in front on every line because I'm not going to move it, I'm not going to change it. This is not f times 5, don't think that. This is a notation that tells me I'm doing a function and I've put in 5 for x. I'm never going to touch that. Okay. So order of operations, I've got the exponent first, so negative 2. 5 squared is 25 plus 3 times 5 minus the 4. And then I'm going to do multiplication or division. So multiplication as we go from left to right. Negative 2 times 25 is negative 50. 3 times 5 is 15, and then minus the 4. Now I can do addition and subtraction as we go from left to right. And so negative 50 plus 15 is negative 35, and minus the 4. So f of 5 is equal to negative 39. And again, if we want the ordered pair, again, if we were going to put this on the coordinate plane or we need it for something else, we can write the ordered pair, and in this case, that would be what? The x is 5, and the y is negative 39. Okay. Example C here. We've got f of x is equal to, what do those vertical bars mean? Remember, absolute value, right? So we'll talk about how we get out of this in a second. The absolute value of 4x minus 5 is equal to, or sorry, for f of 1/2. So again, f of 1/2. Everywhere I see the x, I replace it with 1/2. And so I'm going to bring that f of 1/2 down onto all the lines. Because remember, we're not going to touch it, we're not going to move it. And so remember, we need to work order of operations. The absolute value bars, I cannot do anything with those until I've simplified everything inside of it. And so we got to first do the multiplications there. So what is 4 times 1/2? Well, 4 times 1/2 is 2 minus the 5. What is 2 minus 5? Well, 2 minus 5 is negative 3. And so now I've got the absolute value of negative 3. And remember that an absolute value takes a number and always makes it what? Positive. Remember, we're talking about the distance from 0 when doing an absolute value. And so the absolute value of negative 3 is 3. And so we get the order pair 1/2, not a bracket, 3. So again, if we're just looking to evaluate it, we can leave it at f of 1/2 is equal to 3. Or if we're dealing with a graph, we can write that order pair and then go from there. Okay. So in example 2, we're going to look at graphing and see what it means to evaluate a function from a graph. So let's take a look at those. So as we evaluate functions from a graph, we need to remember that f of x is our y, right? The x that's inside the parentheses is our independent variable, and what it's equal to is the output variable, our dependent variable, right? And so when we look at finding f of 0 or f of negative 2 or f of 3, we're looking for our order pair when 0, comma, blank, or for f of -2, -2, comma, blank. We're looking to see what is the y value when the x is equal to what's in the parentheses. And so at 0, when x is 0, the y value is what? -2, because the order pair is 0, -2. When we do f of -2, we're looking at when x is -2, so we're coming all the way down here and getting our order pair, and that's -2, -8. So this is -8. Now we can write these equal to, so we can do f of 0 is equal to -2, and f of -2 is equal to -8. And so let's talk about f of 3. Find that one. So take a second, pause the video, and see what f of 3 is equal to. All right, I hope you paused the video there. And so f of 3, where's that at? Well, that's the x value being 3. I go all the way up, and I have the order pair 3, 7. So 3, 7 means that f of 3 is equal to 7. So there's no work to be done here in terms of like trying to calculate something. You're going straight to the graph, finding the point where the x is given, and saying what the y value is of that point. Okay, so that's what we look at there when dealing with graphs. This example here, we've got a parabola that's been drawn, and so let's take a moment and look at these three values. We want to know what is this graph when f of 0, f of -2, and f of +1. So I want you to pause the video and try these three out first, and then come back and see what the correct answers are. So pause the video now. All right, so f of 0, that means when x is 0, so that's here. So, oh, look, I'm right here. So I'm at the order pair 0, 0, right? 0, 0. So f of 0 is equal to 0. And at f of -2, so that's when x is -2, I'm at the order pair -2, 0. So f of -2 is equal to 0, because -2, 0. And finally, f of 1, so when x is 1, y is what? I'm at the order pair 1, 3. So the order pair 1, 3 means that f of 1 is equal to 3. And so that's what we're looking at through these problems. And when we do word problems, it's not going to change. We're going to be given an input value, we're plugging into a function and finding what comes out. Now, where we'll extend later on is reversing this. We'll say that f of x is equal to a number, and we have that y value, and we need to work backwards to the x value. That's what's later on. That's what's coming as we go further into algebra. So that's it for today. I hope you all have a good one. Make sure you complete your Google form, and I'll catch y'all next time.